Hey guys, welcome back to the channel. And in this video series, we are trying to complete the SQL course. So basically, I'm going through all the courses that are available on SQL on Datacamp and trying to go through it. So this is the part 4 of the series of called SQL for Business Analyst. In part 1, what we did was we learned about what's in the database. So basically, we learned about foreign keys, primary keys, various things that we can do, and how we can identify a good foreign key. We learned about various functions like coalesce. We learned about cast functions. Then we also learned about in the second part of the video we learned about how we can summarize and aggregate numeric data. There we learned about calculating variance and standard deviation of population, sample, difference between round function and truncate function in SQL, how we can generate a series, how we can calculate the correlation between two columns, how, like, since there is no median function in SQL, how can we use percentile functions to calculate median of a column in SQL. Then we also learned about creating temporary tables. How can we create temporary table? What is the syntax? How we can drop temporary tables? Then in the last video, in the third part, we actually learned about how we can explore and various functions that can be used to explore categorical data and structured data. For example, like there are two types of text data, categorical and unstructured. We can by using various functions, we can extract different features for further analysis from unstructured text. We also learned about the precedence structure when we order a categorical or unstructured or basically a string column. We learned about how we can convert the cases by using lower and upper functions. We learned to do case sensitive and case insensitive searches by using functions like and I like. We also learned about trimming spaces. So basically trim, B trim, L trim, R trim, what is the difference between them? How can we use the trim function to basically remove other aspects than the default white spaces? We also learned about substring function. How can we split text from left, right, middle, or any position that we want to? What is the syntax of these? How can we split text based on a delimiter? Then we also learned about concatenating text. So basically, how can we add add two or more strings? And finally, we also learned about how can we perform multiple transformations. So we learned about a case when method. We also learned about how we can do multiple transformations using temporary tables. So if you guys have like jumped right on this video, then I would suggest that you can go and watch those videos. The link would be in the description box below, because it will really help you understand the entire flow. So yeah, in this video we are going to learn about part 4, or basically how can we work with date and timestamps in SQL, the different functions, data types, formats these columns can have. How can we extract particular values from these? How can we group on them, aggregate on them? What are the various custom aggregation that we can do? And how can we calculate the time difference between these two, between events, etc. So yeah, let's go ahead and start with it. And yeah, if you are new to this video, so what I like to do is I always go through all these videos and exercises, and in videos I pause at certain points and try to explain further or make notes based on like, this is just how I study things. and I would suggest, like, and it would be my advice that you should do that too, because notes help you revise a lot better than just going through the entire video, and whenever a new interview comes or after 4 or 5 months you are repeating the same thing. With notes you can revise everything within a day or two. So yeah, let's start with this part 4.
The last type of data we're exploring is date-time data. As the name suggests, date-time refers to columns that store dates and/or times. There are two main types: date and timestamp. Dates only include year, month, and day. Timestamps include a date plus a time. Times are specified in terms of hours from 0 to 24, minutes, and seconds. Seconds can be fractional down to microseconds. There's also a third date-time type you should know: an interval. Intervals represent time durations. For example, 6 days, 1 hour, 48 minutes, and 8 seconds. Or 51 minutes and 3 seconds. Columns can be of type interval, but it's more common to encounter intervals as a result of subtracting one date or timestamp from another. Intervals will default to display the number of days, if any, and the time. Date-time data can be difficult to work with because people record dates in many different formats. Consider some of the different ways people might write 1 p.m. on January 10th, 2018. They might write the date with either the month or day first. They can use 2 digits for the year or 4. They could spell out the month name, abbreviate it, or use numbers. They might specify the time using a 12-hour clock or a 24-hour clock. To address this ambiguity, Postgres stores date-time information according to something called the ISO 8601 standard. ISO 8601 specifies one way to record date-time information. Units are listed in order from the largest to the smallest, the way we write numbers. Years come first, followed by months, and then days. When time information is added, it starts with hours, then minutes, then seconds. Each component has a fixed number of digits, so smaller values must be padded with a leading 0. Time zones are another way date-time information can get complicated. Postgres stores timestamps.
So this is the first place where I think we should make a note that PostgreSQL. Now, PostgreSQL is basically a dialect of SQL. So basically SQL, like all the concepts and basics of SQL remain same, but by using a different kind of SQL language. So basically SQL, NoSQL, MySQL, PostgreSQL, SQL Server, etc. So some of the syntaxes might change, but like the concepts remain the same. So since in this course we are going through PostgreSQL, so PostgreSQL uses the ISO time, and this is the ISO standard of how time is stored. Or so basically this is a time stamp, not a date, because it includes the date as well as time, right?
Values must be padded with a leading 0. Time zones are another way date-time information can get complicated. Postgres stores timestamps according to UTC, or Coordinated Universal Time. Time zones are defined in terms of their offset from UTC. Timestamps in Postgres can include time zone information or not. When time zones are included, they appear at the end with a plus or minus, followed by the number of hours the time zone is offset from UTC. The example timestamp here is 2 hours ahead of UTC. So how do we work with dates and timestamps? Date-time entries can be compared to each other as numbers can, with greater than, less than, and equal signs. You can get the current timestamp with the now function. This can be useful when comparing values to the current date and time.
Okay, so this is another place where we should make note. So dates can be compared with each other, using less than, greater than, or equal to sign. So basically we can write something like select 2018 January 1st is greater than 2017 December 31st, right? So we can compare dates using this way. Then there is a function called now, which is used to give the current or like the time you are running the code at that particular time, what is the current timestamp, right? So if you write select now, it will return the current date or time whichever you are running the code.
Note how dates in these examples are specified in the ISO 8601 format. They are surrounded by single quotes like character data. In addition to comparing dates, you can also subtract them from each other. The result is of type interval. You can also add time to or subtract time from existing dates. Adding an integer value to a date will add days. Adding an integer to a timestamp, however, will cause an error. Other amounts of time, from years to seconds, can be added with intervals. You specify an interval with a combination of numbers and words inside single quotes, then cast this as an interval. For example, you can add an interval of 1 year. Or you can specify the interval in terms of multiple units, such as 1 year, 2 days, and 3 minutes. All right, it's that time again.
Okay, so like this is another thing to keep in mind is that you can do additions simply but just by using integers, or you can do the additions using intervals as well. So basically if you write 1st January 2010 and then cast it as a date and add 1, so basically it will add 1 day. But what you can do is also do an interval. So basically if you write return 2018 December 10, cast it as a date and add 1 year 2 days 3 minutes, so basic and as an interval. So basically what it is going to return is it is going to add 1 year 2 days and 3 minutes in it. So the answer is going to be
1 year, 2 days, and 3.
Yeah, so December 12 at 00.03 hours, right? So this is going to happen. Okay, let's start with the
All right,
practice.
it's that time again. Time to try some exercises with dates.
Which date format below conforms to ISO? Okay, so ISO is basically year, month, date, right? And then it is a 24-hour format. So answer should be B. Moving forward, date comparisons. When working with timestamps, sometimes you want to find all observations on a given day. However, if you specify only a date in a comparison, you may get unexpected results. Okay. Return 0 even though there were 49 requests on January 20. Okay. This is because dates are automatically converted to timestamps when compared to a timestamp. Okay. The time fields are all set to 0. When working with both timestamps and dates, you will need to keep this in mind. Count the number of events and 311 requests created on January by casting date created to a date. Okay. Where date created. Okay, so where date created is casted as a date. Oh, sorry, where date created casted as date is equal to 2017 0131 45. Okay, count the number of events done 311 requests created on this by using greater than equal to and less than operators. Created on, okay, so basically when date created is greater than equal to and less than equal to, okay, so basically greater than equal to count the number of events done 311 created on, okay, so on February 2019, right? So on February 29. So if I do March 1st, right? So March is 0301, and then I do greater than equal to 2016 February 29, then I think it should capture 58. Okay, then count the number of requests created on March 13. Specify the upper bound by adding 1 to the lower bound. Okay, March 13, 2017, right? So 2017 March 13th, and then less than 2017 March 13 cast as date plus 1. Okay, so I think this should work. 33. Yep, let's move on. You can subtract dates or timestamps from each other. You can add time or date or timestamp using intervals, and interval is specified with a number of units, the name of the date time field. Okay, practice date arithmetic with events and data and now function. Okay, subtract the minimum date created from maximum date created. Okay, so max of date created minus min of date created. So you can run it, and this is an interval. You can submit it. Then using now, find out how old the most recent request was created. Okay, so date created is equal to now. How old the most recent request was created. Oh, okay, cool. So basically how old, so it should be now minus max of date created. add 100 days to the current timestamp. So now is casted as date, and then we add 100. Oh, casting has double colon. The checker expected to find now in there. Okay, so it is basically saying that we don't need to do this, but yeah, this is going to create error. 100 as, or we can do is 100 days as interval. Yep. Select the current timestamp and the current timestamp plus 5 minutes. Okay. Now and now plus you need to do 5 minutes and then cast is as an interval. Cool. Completion time by category. The Evanston data includes a date created timestamp from when each request was created and a date completed timestamp when it was completed. The difference between tells how long a request was open. Cool. Which category of Evanston request takes the longest to complete? Okay. So compute the average difference between completion timestamp and the creation timestamp by category and order with the largest average time. Okay, so from group by category, so group by category, return category, and then the average difference between completion timestamp and the creation timestamp. Okay, so average of date. So what is the name of the column? Date completed minus date created, and then order by average in decreasing order. Oh, order by completion time, because we aliased it right. Yep. Cool. Let's move forward.
As with numerical and character data, sometimes we need to extract components of a date time, or truncate the value, to aggregate the data in a meaningful way. Functions exist to extract individual components of date time data. These components are called fields. The fields are defined in the Postgres documentation. Many are based on the ISO 8601 standard. Let's look at some common fields, starting with the largest unit of time. First, we can get the century or decade that a timestamp belongs in. January 1st, 2019 is in century 21 and decade 201. Date-time field definitions can be complicated and sometimes counterintuitive. It's always a good idea to read the documentation before using unfamiliar fields. Next, we can get the year, month, and day fields that make up a date. We can also get the hour, minute, and second fields that make up a time. Week is the week number in the year based on the ISO 8601 definition. DOW is day of week. The week starts with Sunday, which has a value of 0, and ends on Saturday with a value of 6. To extract these fields from a date or a time.
Okay, so this is another way we can, where we should stop and make some note. So extracting dates, right? So what we can extract various parts. So basically we can extract century, we can extract decade, we can extract year, month, and day as well. We can also extract hour, minute, and second, and we can also extract the week. So it's week of the year. We can also extract DOW or day of week. 0 means Sunday and 6 means Saturday. Okay, cool. Now we need to see how or which of the functions do we use to do these kind of extractions.
On Saturday with a value of 6. To extract these fields from a date or a timestamp, you can use the date part or extract functions. These functions expect a timestamp, but they automatically convert dates to timestamps. These two functions give the same output, they just have different syntax. Date part uses a comma to separate arguments, while extract uses the from keyword. The name of the field should be surrounded by single quotes when using the date part function. With the extract function, the field name can be unquoted. Finally, the extract function, field name, and from keyword are typically written in all uppercase, while the date part function is written in lowercase like other functions.
Okay, so basically how you are reading this is that what to field is basically what you want to so basically in the note you can write that all these are called fields. It is important because then only you can understand about it, right? So all these are called fields, and then there is a function called date part, right? So date part function, there the syntax is basically select date part from the or whatever you want to extract, and then from the timestamp you want to extract from. So for example, if you write select date part and you want to extract month from now, it is going to give you something, right? So so since I am writing this in January, so it is going to give 01. So this is what we mean by this. There is another way to do it, which is called extract. So extract function, basically what it does is same thing, but a different syntax. So you select and basically return extract the field from timestamp, right? So in this case our example becomes select or return extract function, and where we extracting month from now. So this is important, right? So this is also again going to give you 0, 1. So yeah, so these are the two functions that we can use to extract dates. Yep, so let's move on.
The extract function actually calls the date part function. You can see this in the output of the example query. The result of both the call to date part and the call to extract are labeled with date part in the output. The result of one indicates the first month of January. Extracting fields from dates is useful when looking at how data varies by 1 unit of time across a larger unit of time. For example, how do sales vary by month across years? Using sales from 2010 to 2016, are sales in January usually higher than those in March? Instead of extracting single fields, you can also truncate dates and timestamps to a specified level of precision. Remember that dates and timestamps are ordered from left to right, largest units to smallest. You can use the date trunc function, which is short for date truncate, to specify how much of a timestamp to keep, as you might with a numeric value. Valid field types include all of those we discussed except day of week. Date trunc replaces fields smaller than, or less significant than, the one specified, with 0 or 1 as appropriate. Month and day are set to 1, while time fields are set to 0. Here, the year and month remain, and the rest of the fields are set to 0 or 1. Time zone remains unchanged.
Okay, so this is another thing which is very important while keeping or while truncating dates. So for example, the function that we use is called date trunc, right? But the thing to keep in mind is that, so for example, let's say now is December 17, 2018, 21:45, 15.6829 minus 06. So basically it has a time zone as well. Now if you return basically and use this date trunc function, so what it is going to do is we write month and then from now, so it is going to only return so year, month, and then everything after that is going to be 0 0 0 0 0 0 minus 06. So since this is the time zone, so it remains unaffected. So everything basically the ISO standard, basically the ISO standard of dates is in decreasing order, basically decreasing order from left to right. Okay, so when we give the field, in the date trunc function, so in the decreasing order, whatever is left, whatever is equal to or greater than it remains everything else becomes 0 except time zone, right? So this is important stuff. So for example, above we gave field as month, so only month and year remained. Everything else became 0, or basically 0. So basically everything else became 0, that is time part. Date becomes 1 and time zone remains unaffected, right? So this is very important. So just underlining the notes because this is an important thing to keep in mind, because if you don't remember then if you are grouping by stuff, then it is going to create problem, because then like we might be thinking that what we are doing is correct, but ultimately and behind the scenes would be something else, right? So okay, cool.
Set to 0 or 1. Time zone remains unchanged. Truncating dates is useful when you want to count, average, or sum data associated with timestamps or dates by larger units of time. For example, starting from individual timestamp sales transactions, what is the monthly trend in sales from June 2017 to January 2019? Okay, time to start practicing using these new functions.
Okay, so the date part function is useful when you want to aggregate data by unit of time across multiple larger units of time, correct? For example, aggregating data by month across different years, or aggregating by hour across different days. Recall that you use date part as, okay, this is the syntax. How many requests are created in each of the 12 months during 2016, 2017? Okay. So group by what to get monthly counts. So basically how many requests are created in each of the 12 months during 2016 to 2017. Okay, so each of the month, right? So date created, where in each of the 12 months during 2016 2017. Okay, so where date created and we can cast it as date greater than what we can do is 2015 December 31st, and date created casted as date is less than 2018 January 1st. So this is going to have those date ranges. Then what we are trying to do is, okay, so here we need to do count star because counting everything, and then you are grouping by basically month, and we need to extract the month from date created. So date part month from date created. Okay, cool. What is the most common hour of the day for request to be created? Order by count in decreasing fashion. Most common hour. Okay, so date part, then we extract the hour from date created. 9th hour. Okay, during what hours are requests usually completed? Count requests completed by hour. Okay, so this is going to be count star and then date completed, right? So date part, so basically we are extracting it, extracting the hour from timestamp date completed, right? Group by hour and then order by order the results by hour, order by hour. Cool. Moving forward, variation by day of week. Does the time required to complete a request vary by the day of the week on which the request was created? We can get the name of the day of the week by converting a timestamp to character data. Okay. But character names for the days of the week sort is alphabetical, not chronological order. To get the chronological order of the days of the week with an integer value for each day, we can use extract date day of week from date created. Okay, so select the name of the day of week the request was created as day. Okay, name of the day, okay, so here we can write to char, then day of the week, so date created and day, select the mean time between the request completion and the request creation as duration. Okay, so mean time request creation and completion, so date completion minus date creation. Okay, group by day, extract group by day and the integer value for the day. Okay, so extract DOW day of week from date created, order by the integer value of the day of the week using the same function used in group by. Okay, so okay, select the mean time between the request completion and request creation. Okay, so I think it should be casted as date. Let's see. Mean. Oh, it should be average, right? Not mean. Date completed. Oh, do we need to cast? Okay, so we are not casting it. Okay, so as duration basically means interval, right? So we are not. Okay, cool, got it. Date truncation. Okay, so unlike date part or extract, date trunc keeps date times unit larger than the field you specify as a part of the result. So instead of just extracting one component of a timestamp, date trunc returns the specified unit and all larger ones as well. Okay, yeah. Write a subquery to count the number of requests created per day. Select the month and average count per month from the daily count subquery. Okay, so per day. Number of requests created per day. So created per day for each month of the data. Okay, so basically here we are going to date trunc, and then we are doing day from date created. Okay, count star as count from Evanston, group by day. Okay, and then here you are grouping by month. Here you are average daily counts by month. Okay, so this is going to return day and count. Now we are doing date, trunc, month from So month from day, and then average daily counts. So average of count star. I don't think it should be count star, it should be average of. So you are grouping by the month and then you are averaging the day. Let's see. So average daily count dot average of count. Oh, okay, cool. Yeah, I aliased it right, so this should be it. Okay, so okay, so basically what we did here was we from this table evantsend dot 311, what we did was we grouped by various days and counted like for each of the days, if each for each of the days how many requests were created, and then what we did was using that we grouped by month, and then for month we average the counts and to see like on each month what were the daily counts. Okay, so here what we used was is called a subquery.
When counting observations by month or day, the result only includes rows for values that appear in your data. How do you find periods of time with no observations? Recall the generate series function, which you used with numeric data. The same function can be used with date-time data. Generate series expects timestamps for the from and to arguments. Dates will automatically be cast to a timestamp. The last argument is an interval. For example, here we have an interval of 2 days. The result is a series of timestamps between the start and end values separated by the interval. Here's an example with an interval of hours. The last value in the series will be less than or equal to the ending timestamp specified. For example, here the series ends at 8 p.m. on January 1st because the next value in the series would be greater than the 0th hour of January 2nd. To get consistent values, generate series using the beginning of a month or year, not the end. For example,
Okay, so let's back up a little and create note it down. So generate series, we have already learned about generate series in I think the second part of this series, where we use it to basically create in time intro or basically create bins. So yeah, here we are using to generate a series of timestamps. So generate series function where you write select generate series from to and the interval. So For example, if you write select generate series from 2018 January 1st to 2018 February 15th of January 2018, and interval is basically 2 days. Cast as an interval, so basically it is converting it into a timestamp. So this can be done, right? Okay. Generate series from the beginning.
Using the beginning of a month or year, not the end. For example, attempting to generate a series for the last day in each month produces unexpected results. When you add 1 month to January 31st, you get the last day in February, the 28th, because there is no 31st. But then 1 month after February 28th is March 28th, not March 31st. To correctly generate a series for the last day of each month, generate a series using the beginning of each month, then subtract 1 day from the result. Series can also be used to find.
Okay, so this is important thing. So generate series, start 1 month late, and then subtract 1 day interval from it. Okay, so okay, cool. So another thing is to keep in mind is, like, this should also be noted, like, to generate series from the beginning. So select generate series 2018 Feb to 2019 January 1st, 1 month as interval, and then you subtract this entire thing from 1 day interval, right? So this is how we can generate series from the beginning. Okay, normal aggregation
with no observations. For example, you might want to count sales by the hour of the day they occurred. Here's some sample sales data in its original form, and then with the number of sales counted by hour. Looking at the counts, it's hard to tell at a glance that there were no sales in the 11 o'clock hour. To include hours with no sales, generate a series of hours, then join this to the original data to introduce rows for the missing hours. First, use a with clause to create the series of hours from 9 a.m. to 2 p.m. and call this hour series. Then, join this to the sales data, matching the hour from the series to the sales date truncated to the hour. Count the date column instead of counting the rows because we don't want to count null values. Group and order by hours to get the count of sales per hour. The result now includes all hours between 9 a.m. and 2 p.m., with zeros for hours with no sales. We're less likely to overlook that some hours have no sales. If you want to aggregate data by an interval that is not equal to 1 unit of a date-time field, you can create bins. Recall this strategy from working with numeric data. Let's count sales in 3-hour intervals during the day. First, create 2 series, one for the lower bound of each bin and one for the upper. The series for the upper bound starts and ends 3 hours after the lower bound. This is the amount of the interval. We alias the result as bins. Then, join bins to the sales data, where the sales date is greater than or equal to the lower bin and less than the upper bin. Then, group and order by the bin bounds. The result is the count of sales made during each of the 3-hour intervals. Okay, time to practice using series with date-time data.
Okay, so basically now we are at finding missing data, missing dates, custom aggregation, and creating monthly average with missing datas. So the generate series function can be useful for identifying missing dates. Yep, this is the syntax that we use, where from and to are the dates or timestamp. An interval can be specified as a string with a number and a unit of time, such as 1 month. Are there any days in Evanston in this table where no requests were created? Okay, so that is an interesting question. So write a subquery using generate series to get all dates between the minimum and maximum date created in Evanston 311. Okay, so generate series between minimum of the date created, maximum of the date created, all dates, right? So and then there is an interval, so we write it as 1 day as interval. Okay, from write another subquery to select all values of date created as dates from Evanston. Okay, so this is going to be Evanston 311. Select dates that are not in the subquery. Okay, so subquery is basically to select all date created values as dates. Okay, so all date created values as dates, and then where day is not in. um so generate series date 1 day. Okay, we think it should be like this. Yep. Check the highlighted code. Could not find the first entry in the type. Okay, so select generate series. Okay, from date, minimum, maximum, and then we have 1 day interval as day. um okay, so both subqueries should produce values of type date. Okay, so it should be date, I guess, but 1 day. Yep, 1 day. What I think is 1 day interval and then we have something as date. I think this could work. Yep. Yeah, so basically what we did was from minimum to maximum date with an interval of 1 day, and then it said that it should be date because here we are returning date created as date, right? So then we can do not in a particular subquery. Okay, got it. Custom aggregation periods. So find the median number of events and requests per day in each 6-month period. From this, build the query following the 3 steps. Recall that to aggregate data by non-standard date time intervals such as 6 months, you can use OK to create bins with lower and upper bounds and then summarize the observations that fall in each bin. Okay. So use generate series to create bins of 6-month intervals. Okay. Recall that the upper bin values are exclusive, so the values need to be 1 day greater than the last day to be included in the bin. Yup, correct. Notice how in the sample code the first bin value of the pound is July 1st and not June 30th. Yep. So first bin value, last bin value, it is going to be between okay, 30th June 2018. So 2018 June 30th, and then we are going to create 6 months, right? So 6 months, and then what we are doing is between last bin upper value, so it should be six-month interval. So it is going to be 30th June Okay, so it should not be 30th June, right? So 6 months before 30th June. It should be January. mm, yeah, it should be January, right? So it should be 01 01, and then here we should have 2018 and 7 and 30th. Six months. So okay, seems good. Then count the number of requests created per day. Remember to not count star or you will risk counting null values, correct? Per day, okay. Include days with no request by joining events into a daily series from, okay. Okay, so date created as date, Evanston, left join, generate series. So daily series. So daily series is basically from 2016 first to 2018 6:30 1 day interval. Okay, and then we are counting the number of requests, right? So number of requests, so we are basically counting ID, group by day. Okay. Assign each daily count to a single 6-month bin by joining bins to daily counts. Okay. So this one is here, and percentile discontinuous function compute median of count for each bin. Okay, so percentile 0.5 within group order by count. Okay, and this is the median, and left join daily counts on day greater than equal to lower, greater than equal to lower and less than upper, group by bin bounds. Okay, so group by lower and upper. Okay, cool. Monthly average with missing data. So, and what you are saying here is common table expression. So in the next series, I'm going to go over the SQL fundamentals, and we can discuss more about common table expressions. And then you guys, if you want, you can go through it and then come back and understand more. So basically, it is what all it is doing is this entire query which is inside this with clause is basically converting it into a common table expression, and then instead of writing all this 10 times, you can just use whatever is returned from the query inside it by referencing all days. So monthly average with missing data, with missing dates. Find the average number of the requests created per day for each month of the data. This time do not ignore dates with no request. Okay, so generate a series from so 2016 1 then series of dates, so basically 1 day interval, 2018 June 30th, 1 day interval. Okay, daily count, select comma, so all days, then daily count as date truncated from date created, Evanston. Okay, aggregate daily counts by month using date truncate. Okay, so date trunc month from date created, the date which has all dates, not day. Okay, which has all dates, cool, and Okay, so which has all dates, not day. So here I think we need to get date. And then use coalesce to replace null count with compute the coalesce all days dot date is equal to daily count dot day, and we are average of null count values. So count star, and if it is null, then you give it 0. Null count values. Okay, so coalesce. So from all days, okay, all days left join daily count. Okay, so here we should have count, and then if this column is null, then you return 0. Cool. Okay, time between events.
You know how to subtract one date from another. But how do you find out how much time has passed between events when the dates or timestamps are all saved in the same column? For example, here is data from a sales table with a timestamp for each sale. Our question is, how much time passes on average between each sale? The lead and lag functions let us offset the ordered values in a column by one row by default. Then we can subtract the original values from the lead or lag of the values to get the difference between events. Before we talk about the syntax, let's look at the results of the function calls. The lag function pushes all of the values down one row. Null is inserted at the beginning of the lag column so that the first sales time at 9:07 is now the second value. The last sales time is discarded. The lead function does the opposite, pulling all values up one row. The second sales time of 9:13 becomes the first value, and null is added at the end of the lead column. The first sales time is discarded. Okay, back to the syntax. For the lead and lag functions to work, you have to specify how rows should be ordered. Remember that the rows in a database table have no inherent order to them. They are only ordered when you explicitly specify an order. Lead and lag are window functions. You start with the function name and supply the column you want to apply the lead or lag to as the argument. You then add an over clause with the keyword over and an order by statement specifying how the rows should be ordered. The order by statement goes in parentheses. In this example, we have ordered by the same column that we want to lead and lag, date. But this isn't a requirement. We'll see an example where these columns are different shortly. But first, how do we use lead and lag to
Okay, so this is an important thing. So lead and lag basically are examples of window functions. So window functions are basically, comes in handy. You can understand it as, so there are a lot of times or a lot of questions that can be answered using group by, but sometimes what happens is that you cannot do, because while you group by, so when you group by certain things, right? So what it does is you can only calculate or get things that are on aggregate level, right? So basically group by various categories, group by various years, etc. But there are other questions, like if you want to know the rank of a particular group, if different countries and which events or sports they participated it in Olympics game, how many gold, silver, bronze medals they won. So like when once the question is in front of you, you will be able to understand it a lot better. But there are a lot of questions, like for example running total, right? How do you, or reigning champion, so how do you know, like how can you use group by to calculate it? Like it is very difficult to use group by to calculate running total or reigning champion, etc. So in that case, window functions come in very handy. So lead and lag are basically an example of window functions. So basically what they do is, lead is basically so the next date or the next, so whatever lead, so whatever is written inside the column name inside the lead function, it takes that, orders by that column, and then takes the next value and assigns it. So you can write this syntax that is important. So select date, lag of date over. So basically anywhere you see over, you can be sure that it is a window function. So all window functions have like this thing in mind. Like this, there is a syntax. So there is a function, and then there is over, and then inside the parentheses you have everything like partition by, proceeding. So like there are a ton of, so over can be there can be nothing inside it, as well as there can be partition, order by, etc, etc. But if you see over, you can be sure to say that it is a window function. So lead, date, over, order by, date from a particular table called sales. Also, another thing that you should keep in mind is that the order by inside so if you go and Google the order in which the SQL queries run, right? So which function runs first and which function runs later. So order by is one of those functions where which is which runs almost at the second last. So like when everything is done, then you order by and then you limit. So limit is, I think, the last one to run. But if there is order by outside a query and inside this window function, so inside the window function takes precedence, and then only there would be order by. So here in this case, what it will do is, so from this, so this line will run first from this table, then there would be order by, dates, and then lag and lead columns would be generated. And let's say there would have been order by, say, date, right? So then that order by would have been executed in the last.
Shortly. But first, how do we use lead and lag to compute the time between sales? If we order dates from oldest to newest, we want to subtract the lag date from the current date to compute the gap between each sale and the previous sale. We have one less gap value than the number of sales. To compute the average gap, we need to use a subquery. We cannot simply wrap the average function around the difference between sales, because window functions can't be used inside aggregation functions like average. The average time between sales is 32 minutes and 15 seconds. The lead and lag functions are not limited to date time data. As mentioned before, you can order the rows of the table by one column while getting the lead or lag of a different column. We often want to do this to compute changes in a time series. A time series is any variable that has a date or time associated with each value. Here, we want to see not how much time passes between each sale, but how the amount sold changes from one sale to the next. We can't compute a change for the first value in a time series because there's no previous value. Looking at the change column, for the second sale, the amount was 19 less than the first sale. The last sale was 35 more than the previous sale. All right, with that, it's once again time to practice. On to the exercises.
Okay, so I think there are only two exercises left in this. Yep, longest gap and rats. So what is the longest time between events and requests being submitted? Okay, so lead, lag. Select the date created and date created of the previous request using lead or lag as appropriate. So with previous, okay. And compute the gap between each request and the previous request. Select the row with the maximum gap. Okay. So with requests as, okay, so date created, lead or lag. So previous one, right? So previous one would always be lag, right? So you are lagging behind. So lag of date created over order by date created as previous. Compute gap as date created minus lead or lag. Okay, so lag over order by date created gap. Select the row with maximum gap. Okay, so select max of gap. 2 days, 37 minutes, 25 seconds. Okay, requests in category rodent rats average over 64 days to resolve. Why? Investigate in 4 steps. Why is the average so high? Check the distribution of completion times. Date trunk. Okay. See how excluding outliers influences average completion times. Do requests made in busy months take longer to complete? Check the correlation between the average completion time and requests per month, and then compare the number of requests created per month to the number completed. Okay. So use date function to examine the distribution of rat request completion time by number of days. Okay. So date trunk and date trunk, for date trunk the syntax is day and date completed completion times by number of days. Oh, okay. So completion time. Truncate the time to complete request. To the day, okay, and then count requests with each truncated time. Rodent rats group by completion time, order by um, distribution of rat request completion times. Okay, so if I order out on count, I think I should order it on completion time. Oh, okay, date completed subtracted by date created. Okay. Compute average completion time per category excluding the longest 5% of the requests. Okay. So select category average completion time from Evanston where completion time is less than. So where average completion where completion time is less than 95 percentile. Okay, so where completion time is less than so 0.95 within group, order by from Evanston where completion time is less than average completion time is including the longest 5% of the requests. Okay. Category is average of completion time. Order by completion time average completion time per category. Okay. So there is a category, there is completion time. So compute average completion time per category excluding the longest 5% of requests. Let us take a hint. See, so you can't use an alias in a where clause or subquery. Use the full expression instead. Okay, cool. Remember, okay, and okay, so I guess this is what we need to do. We cannot use this. From Evanston where, okay, yeah, got it. So this completion time, there is nothing called completion time here. Yep. Then get correlation between average completion time and monthly request. Extract epoch from interval, returns seconds in interval. Okay. So from convert date created to its month with date trunc. Okay. So from select date trunc, month, date created, and then compute average completion time. So average, okay, and then what we are returning is correlation between average completion time and monthly requests. Okay, so month and average completion time. Average completion and count. Select the number of requests created and number of requests completed per month. Okay. Date trunc, month from date created, created count, completed, date trunc, month, date completed, and then from created inner join completed on month, completed dot month, created dot month, and then number of requests created. Okay, so created count, and then it is completed count. Okay.
Congratulations! You've made it to the end of the course. I hope you've enjoyed exploring the Evanston 311, Stack Overflow, and Fortune 500 data. If you'd like to continue practicing with the data used in this course, you can download the data and the SQL file used to create the database from the course landing page. As you continue to explore this data or start working with your own databases, I'd like to leave you with a few parting tips. First, time spent on exploratory data analysis is never wasted. Understanding your data in depth before moving on to more complicated analyses is essential. Second, use the Postgres documentation. It provides examples of how to use the functions covered in this course and additional ones you may find useful. Third, be curious. Ask questions of your data. See what you can find out. Verify your assumptions with the data. Fourth, don't compute summary measures, such as the average or variance, without first looking at the distribution of your data. Data is never as clean as you'd like. Always check for errors and expect to find them. Summary measures are useful, but they aren't a substitute for understanding a variable's distribution. All right, that's it. Now it's time to start exploring databases on your own.
Okay, so basically we have completed this, So this entire exploratory data analysis with this. And so like, yeah, let me know, did you guys find it useful? Should I continue it? Or and if you are watching this later, like I am most probably going to do it, so you can find the link of the next video in the description as well. And then yeah, like, share, subscribe, and you know, with this, like, there are other tracks as well. So like if I can go to skill track, SQL, so we have done 1 out of 5, so basically that is why 20% of this track is completed. I am also planning to start with this, because this is going to be a lot fundamental course, because some of the things in this are somewhat advanced. So if you are, you know, looking for a course where you want to understand SQL from a much basic level, so you can watch the videos. There would be link in the description. Also SQL fundamentals, so if you see, like I have completed this on my own, so and this was very like it was an amazing collection of knowledge which I even use in to get into one of my companies currently. So, and this is going to be exactly the same, the only difference being, like here it was we were using PostgreSQL, now we will be using SQL Server. So might be a minor changes in syntaxes, but the concepts are almost the same in both of these. So you guys can, you know, watch these courses as well. So yeah, like, share, subscribe. Let me know if you guys find it useful, and is there any other course which you want me to do. So so right now I'm focusing on SQL. So once I complete all these, I would also work on spreadsheets. So basically Excel, because even though even though I am a senior data scientist, I have to use Excel a lot in my day-to-day activities, and I have learned a lot, but there is still a lot that can be learned. So apart from learning this myself, like I can share with you guys what we learn, and then we can learn it together. And once we do this, then Python, it is going to be the longest stuff, because it has so many things to do. So yeah, but yeah, once I complete SQL, so because currently my complete SQL challenge is going on, so after this there would be complete spreadsheet, and then after that it would be complete Python course. So stay tuned, let me know if you guys have any preferences which I should start. So I am thinking of starting with Python fundamentals, so don't worry, I will reset this thing to 0 and then do it, so that none of you feel that I am starting it in between. I would be doing that and covering everything. It is not only helping me revise these stuff, but if let's say you have already gone through and you think that you have been doing Python for a couple of years now and just want to have a quick rundown, it is also going to help you. But if you are very new to it and just trying to learn about it, you can watch it and learn, make notes, etc. So yeah, let me know how it goes, how do you find this, and we will meet soon. Take care, guys. Bye.